All right. Good morning, everyone. My name is Kevin Maselli. I'm one of the founding members of Invigilator Solutions. We are a student company that is being formed through the University of Central Florida through their capstone course and their Entrepreneurship for Defense courses. We have a government sponsor from Southcom as well as heavy support from the Defense Innovation Unit, and want to thank them for all their help. They've been paramount to our accomplishments and development of this product and business. Currently, there is a large lack in surveillance for maritime environments. This allows drug smugglers, human trafficking, and is overall a large breach in national security. Current solutions to this are very expensive, including aerial approaches. They're non-scalable, and the equipment that is sold to the government is very expensive and burdens them with ownership, maintenance, operation, and many other factors that go into owning the actual product. The solution that we're developing is the Maritime Domain Awareness System, or MDAS for short. This is an array of radar sending units. They're self-sufficient. They're going to exist on commercial vessels, local condo buildings, and buildings on the coastline, such as the one that we're on right now, as well as fixed structures on the ocean, such as oil rigs, cell towers, and any other place that we can mount these. And what it's going to do is it's going to enable us to have an array of overarching radar data for open ocean and coastlines. We're going to be components off the shelf, allowing for us to have a readily scalable system, and we're going to be only selling our data. We're going to be using a subscription-based data per hour, where Invigilator Solutions is going to own, operate, and maintain all of it. And we're going to be only offering a solution to our beneficiaries. We're going to offer them an interface where they can see all of this radar data in one location and take all of the burden of ownership onto ourselves. There's a range of applications for this, including drug smuggling, human trafficking, search and rescue, SOS operations, including national security, maritime traffic monitoring, and any other system that requires historic data. We can offer trends on maritime traffic on any given day if they're in our ranges, and as well as we've explored is for counter UAS as well, using this application for radar and having these self-sufficient radar nodes deployed. I'm going to go ahead and share my screen to show you exactly what we're looking at over here on the condo building. Right now we're in Stinger Island, and we have our radar set up on top of a condo building, as you can see behind me.
On the left, we can see the MDAS software we have been developing. It is ingesting live radar data from our 6-foot Simrad radar on the roof of the 18-story condo building we are in Stinger Island, Florida. On the right, you can see the public marine tracker, which will be used to verify the location of ships we detect with and without transponders. We are uploading the data from the radar entirely using Starlink, which will enable our minimally invasive, readily deployable, and remote location operating abilities. Right now the team is analyzing data we are collecting on the radar and cross-checking it with the marine tracker to identify vessels and determine if they have active transponders. Using the MDAS software, we can see we're picking up over a dozen vessels comprising of boats with and without transponders. In this case, they're mostly private fishing and recreational vessels. One of the vessels we were able to see is the Gigi, which was able to be successfully identified as a transponder carrying vessel. We're going to keep analyzing the data to find a few more live examples of the transponder versus non-transponder vessels. So we were able to detect and identify an additional vessel, the Second Love, using our radar. And on the right, you can see that on the public marine tracker, we were able to verify this. While this demonstration shows the ability of one of our units, the full MDAS system will encompass the scaled deployment of radar units on coastlines, fixed structures, and commercial vessels to create an array of radar data across hundreds of square miles. This overarching radar data will be offered as a data subscription service designed to provide persistent maritime domain awareness in areas that currently lack effective surveillance coverage. It requires no acquisition, no maintenance, and no sustainment from the end user. Our platform is built for scalability and easy deployment, offering persistent surveillance through a network of software-managed radar nodes. We're currently testing and refining the system performance in live maritime environments with the goal of standing up a mesh of MDAS units along high-priority maritime regions. This will allow for overlapping data zones and the ability to track vessels from one node to the next as they transit across monitored areas. MDAS is being designed with a wide range of DoD and interagency mission profiles in mind. This includes counter-narcotics operations, human trafficking deterrence, monitoring of vessels of interest, including those that may not follow standard electronic identification protocols, particularly in areas of strategic concern, search and rescue, post-hurricane and natural disaster recovery, special event maritime security, such as high traffic port shows, as well as many other applications benefiting from the utilization of live and historic radar data trends. These use cases all benefit from the system's emphasis on historic data retention, multi-jurisdiction data sharing, and low latency awareness across a distributed area of interest. By providing a persistent, software-driven layer of maritime visibility, MDAS aims to bridge the gap between momentary detection and long-term pattern recognition, enabling more informed operational decisions across defense, security, and disaster response domains. Currently, our software team is actively developing core capabilities, including object detection and traction, identifying bearing, speed, and course, with plans to overlay AIS data where available. Historical tracking, allowing operators to have access to past vessel movement patterns for situational awareness, investigations, or search and rescue planning. Weather integration, collecting wind speed, direction, and barometric pressure data to aid both in maritime situational awareness and weather event analysis. We're also working on implementing tipping and queuing analysis, which can easily monitor specific vessels or behaviors of interest over time. One of the driving principles behind MDAS is simplicity in the field. The system is designed to be easily deployable, allowing teams to get up and running quickly without specialized infrastructure or lengthy setup. Everything we build is designed with the operator in mind. This system will be weatherproof and tamper-resistant, backed by 24/7 monitoring. It's completely self-sufficient, with redundancies in place to ensure uninterrupted data collection and relay. From the end-user's perspective, there is no physical interaction or upkeep required. Everything is remotely managed. Our software and data architecture are optimized for rapid deployment, even in remote or infrastructure-limited regions. Whether it's coastal buildings, a mobile platform, or a temporary outpost, MDAS is designed to scale with mission needs. In addition, as technology continues to evolve, so does our platform. We're committed to continual software upgrades, integrating better algorithms, clearer visual tools, and features that reflect direct feedback from operators and mission planners. Importantly, all MDAS data is relayed in real time via Starlink, enabling uninterrupted connection even in remote environments. The long-term vision is a multi-node mesh that provides full situational coverage of a coastal region and inland waterways. Our software infrastructure is also being designed for flexibility to fit the formatting and needs of the user. We believe MDAS can be a force multiplier for persistent maritime awareness, enabling detection for non-cooperative, non-squawking vessels, archiving of movement data for actionable intelligence, and expanding surveillance into previously unobservable zones.
I think we can see
nautical miles the closest target crossing.
0.3.
0.3. You can see him heading north.
0.3. Yeah, as you can see here, passing over the mouse here on the right, past this dotted line, is one of the vessels that we're seeing passing right in front of us at the condo building. Do you want to put the camera over the ledge and look over? Yeah, thank you, Trevor. I'm going to go ahead and pull up YouTube as well. It should be loading. There is a little bit of a delay, but it should go to the side in a second.
Secondary target is south at 0.76 nautical miles. That's this guy right here. So this guy's 0.6. This guy right here is 0.6, yep. You can
Yeah, as you can see on the right here, Trevor is recording that boat passing by. We found an additional vessel, 1.6 miles due right.
on the marine tracker.
Yeah, see if we can pull this up on the marine.
Click on the actual targets.
we're going to extend our target area and look for vessels farther offshore. At our height, we should be able to see around 50 miles of usable data, which can be increased with higher altitudes of MDAS mounting locations. Additionally, we were able to track up to 50 vessels at once using our current radar model, which we plan on upgrading these abilities as new radar advances are developed, ensuring our system uses the most current technologies. Right now we're refreshing the radar to be at an extended range. As we increase range, we're still able to see vessels past 40 to 50 miles. However, the trackability does degrade somewhat. We're able to track those 50 vessels best around 20 miles. You can see on the top right, we're also picking up a little bit of storm weather. That's one of the abilities of our radars. We can pick up weather, and we're able to adjust our calibrations based off of that to get the most clean radar data. So we just picked up a few cargo vessels offshore. As you can see on the right, the Tropic Night, we're able to pick that up in our outer bands of our radar at its current configurations.
We are nearing the end of the demo. I want to go ahead and thank everyone again for coming, and please fill out that form for the feedback. Furthermore, thank you again to Southcom and DIU for their involvement. I'm going to put our email one more time into the chat,
It is in the quad charts
as well as it is on the quad charts on our website.
This site will be here, so they can always look back at it.
Yeah, and that site will always be up. So we can all those resources, all of the quad charts, please,
Share them, whatever.
share them, utilize them. It'll be a great help. Thank you.
And we are open to more.
We are going to stick around after 11. If anyone has any questions, please feel free to enter them in the chat or unmute yourself.